In this video, I'm going to solve some questions which are based on the chapter exponents and power, right? And for class 8. So let's begin with the first question. In the first question, we have to write this in the scientific notation. So we know how to write the number in a scientific notation. So in a scientific notation, we have to shift this decimal, right? The decimal which is over here has to be shifted 1, 2, 3, 4, 5, 6 over here, right? So now if I write this, it should be what? 5 point. It should be 5.42. As you can see, we have shifted the decimal to the right. Now there is some confusion among students. Should we write a positive or a negative power? Now clearly this is a very small number, must be a negative power. So this is the answer for the first part. The next question is the question number 2 is to write them in the standard form. So in standard form, that means we have to write this in decimal. As you can see, it has a negative power, so must be a very small number. And for that, we are going to shift the decimal towards the left. And how many places? As much power is there. So we can see that if I write this, like say, if I write 532, and I can see that we have to shift the decimal 4 places left. So the decimal is over here. So 1 place over here. So let's place some 4 zeros here. Now check here. We have to, the decimal is over here. So this is 1, 2, 3, 4. So decimal has to be shifted to this place. So it's actually 0.000532 should be the answer in the standard form. The next question is, I think they mean to write simplify here. So if I simplify, the first thing that we will do is to convert them into a positive power, as you must be knowing that reversing the sign of the power is like on reversing the sign of the power, we have to reciprocate the base. So the base on reciprocating becomes -3/4, and this power will become positive. So we know that a raised to the power -1 is 1/a. Applying this property, we can write this as -4/3 raised to the power 2. Now 4 square is 16, and you know that with an even power, the minus become positive, and 3 square is 9. So therefore, 16/9 should be the answer for this part. The question number 4 is to find the value of this. So we know that any number raised to the power 0 is 1. And applying these two properties, number 1, a raised to the power -1 is 1 by a. So let's deal with this part first. So we are going to write this as 3/2 raised to the power +2. And as I said that any number raised to the power 0 is 1. So this will become 1. So simplifying it further, this is 3 square 9 and 2 square is 4. That multiplied by 1 should give you 9/4. Question number 5 is to simplify. The question is based on laws of exponent. So as you can see that we are going to look into the first two numbers here. These have the same basis, right? So we'll be solving this part first. But before that, let's write down the exponents rule here, the laws of exponent, that is a raised to the power m into a raised to the power n is equal to a raised to the power m plus n. So when you have same basis multiplied, power should be added. So we can write this as 16 raised to the power 0.16 plus 0.04. And that multiplied by this, which is 2 raised to the power 0.2. Now for further simplification, as you can see that these two, on adding these two, 0.16 plus 0.04 is what? 0.20. So this will give you 0.20. Let this be as it is, 0.02. Now I can write this in fraction, which is 16 raised to the power 0.20 is what? 20/100, which is 1/5. So you can write this as 1/5. This has 1/5, and this is also 0.2, that is 2/10, which is 1/5 only. Now check here, we have different bases here, but I can write 16 as a power of 2, that is 2 raised to the power 4, that multiplied by 1/5 into 2 raised to the power 1/5. Further, you can multiply this and write this as 4 over 5 and this as 2 raised to the power 1 over 5. Now check applying the same law. We can say when we have the same basis, the powers will be added. So we'll be adding the power, which is 4 by 5 over 1 by 5. That will give you 2 raised to the power 5 by 5. They get cancelled to give you 2 raised to the power 1, which is 2. So the answer for this will be 2. The question 6, we have what is the area of a rectangle whose length is 3 raised to the power 3 meter and the width is 9 raised to the power minus 2 meter. So we have to find the area. So what do we know that area of a rectangle is length multiplied by breadth. So this area length, which is 3 raised to the power 3 and width, which is 9 raised to the power minus 2. 3 raised to the power 3 is 27. But this I can write as 9 raised to the power positive power 2. As you know that a raised to the power minus 1 is 1 over a. So this is 27 multiplied by 9 square is 81. I can reduce it 27 3 times. So 1 over 3 meter square or square meter is what should be the area of this rectangle. The next questions, which is based on the laws of exponent here, we have to simplify this. Now, first thing that we will do here is to resolve the negative power. As you know that on reciprocating the base, the power become positive. So I'm first identified. First of all, I'm going to write these numbers with negative power as positive by transposing it. By that, I mean to say if it is in the denominator, write it in the numerator. Like this is in the denominator, write it 3 raised to the power 6 with a positive power. This will come below and should be written as 3 raised to the power 4. And finally, 6 raised to the power minus 3 can be written as 6 raised to the power 3. Further, I missed one more number which has a negative power, that is 10 raised to the power minus 2, which can be written as 10 raised to the power positive power 2 in the numerator. Well, with other numbers which has a positive power remain here, like I can write 25 as 5 square and 16 as 2 raised to the power 4. Now, what next I'm going to do is to apply whenever there is a laws of exponent possible here. So I can reduce this part, right? Same basis divided, power will be subtracted. So applying this is a raised to the power m over a raised to the power n is a raised to the power m minus n. So I can write this as 6 minus 4, that is 2. This is 3 raised to the power 2. Further, I can write 10 as what? 2 into 10 can be written as 2 multiplied by 5. 10 is 2 into 5. So I can say that this is 2 raised to the power 2 as there is a power and 5 raised to the power 2. This is 5 raised to the power 2. Below I can write 6 as 2 into 3. So it's 2 raised to the power 3 and 3 raised to the power 3. And this remains as 2 raised to the power 4 here. Now, what next we can do here is to apply more power. I'll apply laws of exponent between these two and also between this and this. So if I simplify it, I can write 3 square as it is, 2 square as it is, and this can be written as 5 raised to the power 4. That whole divided by these two can be written as 2 raised to the power 7, and this is 3 raised to the power 3. Now, for further simplification, what I'll do here is we'll be solving these, applying laws of exponent between these two and also between this and this. So let's say if I do what I'll get here. Between these two, I'll get 3 raised to the power 1 here. Between these two, I'll get 2 raised to the power 5. Yeah, 7 minus 2 is 5. And this is 5 raised to the power 4 in the numerator. 5 raised to the power 4 is 625. And this is how much? 32. And this is 3. So 32 into 3 is what? 96. So it's 625 over 96 should be the answer for this part. The question number 8, which is also based on laws of exponent. So before we proceed, if I ask you what is x raised to the power n over x raised to the power n. You may say by applying laws, we can write this as x raised to the power n minus m. Now, same thing we can apply here. So that means if I can write this as this, it means I can write this as this also. So this is what I'll apply while solving this question. So this is 1 over 1 plus, as I said, this can be written as this. So I'll be writing this as x raised to the power n over x raised to the power m plus 1 over this 1 plus this 1 over here plus the same way, applying the same property here, I can write this as x raised to the power m over x raised to the power n. This time it is just reverse of it. Let me write down. This is x raised to the power m over x raised to the power n can be written as x raised to the power m minus n. So I can write this as this. So this is what I applied. Now, if I take LCM over here, on solving this part, the LCM clearly is x raised to the power m. There is nothing, so it will be multiplied by x raised to the power m plus x raised to the power n. This side we have 1 over x raised to the power n. Let me take the LCM first, plus x raised to the power n. Now you see that, you know that 1 divided by any number is the reciprocal of this. So on dividing is same as multiplying with the reciprocal. So I can write this as x raised to the power m over, this is on the power, this is the base, that divided by x raised to the power m plus x raised to the power n. And for this part, same way, it's going to be x raised to the power n whole divided by x raised to the power. So writing a plus b same as b plus a. So I'm writing x raised to the power m plus x raised to the power n. Now clearly the LCM is going to be x raised to the power m plus x raised to the power n. This will be x raised to the power m plus x raised to the power n. Check here that we have same numerator and denominator. We get cancelled to get 1. So 1 will be the answer for this question.